Hey all, welcome to another episode of Saturday Architecture. We're going to look at part two of the CrowdStrike. In part one, we considered three parts. There's a manufacturer, and then there is a supply chain, and then there is the actual end delivery point. If you look at it in a pharma scenario, the drug where it is manufactured, the supply chain to which it's shipped, and the final place where it is actually administered at the hospital or at the home where the patient is going to consume it. So we're looking at what went wrong or what could have been done right at the middle part of the supply chain. And in this case, as far as CrowdStrike goes, we could consider that as, let's say, the IT which was involved in taking the patch and making sure it's getting applied on the servers and machines. So that would be the supply chain that is involved in the whole process. So maybe I'll start with Vamsi. What could have been the things that could have been done better from that perspective, right? In terms of IT ops, whether you want to call it DevOps, IT ops, what it should, ideally, it should not have been a disaster as it happened, right? So I'm sure there is some part the supply chain also had to play. So what's your take on that?
Yeah, so distribution traditionally, right, if you look back, we used to have everything centralized, right? Then we went to client server, where software is distributed with CDs, if people remember those, right, or floppy drives, and then the software, even if there is a glitch, the amount of time it takes to take effect used to be several weeks, months, and sometimes
Uh,
years. So that used to be the case with the cloud applications, everything being centralized. We used to have that cascading effect. So some problem comes immediately. It used to kind of spread very very fast, right, to multiple users and multiple geographies. So extending that further, we extended whatever is the distribution model for business applications to system software. In this case, a security software, an end edge agent, right? That has kernel access. Now, companies which have an established practice of propagating a change using a pilot model where they control where that software gets affected, let's say like 5% of the user base, then expand it to 10%, 15%, 20%, like that. Whoever could do that kind of a distribution model most likely will not get affected, right? But in this case, it's possible that the companies which got affected have that all or none, right? They open the floodgates. Maybe they did not know the level of impact this distribution problem could cause, particularly if it has a catastrophic bug like it happened in the CrowdStrike. So, in other words, it's the supply chain. The supply chain can take good things fast, but it also can take bad things faster. That's what happened in this case.
so can we, for example, can we in this case, right, Vamsi, we can say that the IT architect, okay, the infrastructure IT architect, if a question had been asked, what happens if a rogue patch comes in directly? What would happen here? Right. So how do I ensure something like that? Would I be right if I kind of understand that's the point you're alluding to?
Exactly. The fundamental question, the role of the architects. The role of the architects is not designing a system. They are not. It is not developing a system. It is not controlling the business architecture to the IT architecture. Its overall risk management is one of the built-in role. Right? It is one of the built-in requirements for a good architect. Now, in this case, it's a balance. So, can an architect recommend critical security mitigation software like CrowdStrike, where signatures for the new threats are being propagated? Can he recommend go slow on it? Probably not. But can they say release every software as fast as you can to all the edge devices en masse for the entire field? No, I don't think so. So there is a architects have a role to play by balancing or trading off security to overall availability risk. So
Yeah.
that's what I feel here.
Interesting. So I was having a discussion about some blood donation yesterday with friends of mine. And one of the things is every time a blood enters a blood bank, right, they do a test on them, right? And they keep checking whether it has got infected or it is fine. And before it is sent out. So when it comes in, there's a check. And then before it goes out also, there is a check. It's not like blood came somewhere, I just stored it and then I gave it back. So the blood bank also takes a kind of responsibility for it, even though it comes from somewhere. It's assumed that it is taken well, and the ones who are going to administer it is going to do a test before infusing blood, right? So, similar to that, Deepak, what could have been the things that could have been done here, such that it's like naked options when we do trading, right? It's like completely exposed.
Yes, completely. So when Vamsi was talking about it, and you also mentioned the word DevOps, and people number of times just thinks DevOps is somehow the magical pill that will cure some of these things. Ops is still ops, right? You still need to do the operations irrespective of who is actually doing it. And designing operations is very much part of the architecture uh, of how some IT infrastructure, I would say, is just going from my service management background, is how a service is supposed to run, right? Service architecture, right? So I'm just going into the higher level of abstractions. This is the end-to-end something you're providing IT, whatever the infrastructure service is, right? It is dependent on some other service, and you build that stack over using different components, and key component being security. And say, now, could it have been done better? Definitely, yes. It comes back to also, you see, this is in the DevOps, they have this, they call it the error budget, right? How many times you have failed in the past, that will decide how rapidly you are allowed to deploy, right? So now, just because of this incident, we might see some improvements, right? Now we have understood that this is a dangerous thing to let people willy-nilly deploy stuff to critical infrastructure without actually having some level of sanity test, right? In this case, obviously impacting the kernel. If they had just simply deployed it on some test devices, it would have not taken more than 15 minutes, my view. Right? It would, the speed would not have been impeded of deployment by more than 15 minutes. Right? I know 15 minutes is a long time in the security world, right? So you can bring down whole sets of infrastructure in that. But this has to be built into the risk management which is there, right? So, okay, we will try it on the sample critical infrastructure we have, because our critical servers which run XYZ critical services, these are the sample representative. We are going to run any critical updates through this system. If it fails, it's like a DevOps pipeline in that sense, right? It can be automated, right? It can be automated and say, okay, nothing happened, and it went through. So it could have been done better. Now, the reason it did not happen, I'm just going into the fact that why it did not happen. Because of the fact which I said earlier, that their error margin was so good earlier, right? It is like they had never failed in the past, right? So we trusted them. He says, okay, you have done very well 99.99% of the time, we will let you go, right?
Because it's going to be cloud. They had 10 infra architects. Now there are 2 infrastructure architects. Maybe it's a bandwidth issue. Somehow, I think this is kind of leads to what you were telling also.
No, I think, since I am a mechanical engineer by training, and I relate to cars and all those things very well, I will tell you the analogy, right? See, until some parts start failing rapidly, you will not see indicators for those in your dashboard, right? So it all depends on the reliability. As my final year project, I built an indicator for oil filter being clogged, right? I did it for tractors, of course. Right? So I'm just giving example, right? So nobody thought of that thing that, okay, do I really need an indicator if my filter is clogged? I can just maybe If some engine does not start, maybe because the oil is not going and all those things, I will do all that. So it's incremental in that sense, right? Those dashboards and the indicators get built on the reliability of the parts, right? Now, if the moment we start suspecting reliability of something, in this case, any kernel level updates, you will start getting these dashboards into your thing. And so this incremental, so it's a good thing. It did not impact a very large number of the people. So at least is a lesson that anything of this kind can have a larger impact. And now you will start seeing all network monitoring and all these things start getting this into their dashboards as to see what updates are going into kernels at critical infrastructure, and you will start seeing that. It's a sort of a loop by
Yeah,
itself.
you will be surprised.
And it's a seesaw. It's a seesaw. The moment it becomes reliable, this dashboard will start going into the background. The moment it becomes unreliable, the dashboards come to the front. So this is a operation seesaw. I have seen this cycle for the last 30 years. I think from the supply chain perspective, this is normal behavior, right? In the sense that now you will suddenly, because they have experienced it,